give a lecture. He's one of the creators of React, so I'm really happy to have him here. And he was at Instagram and then Facebook, and then recently he left Facebook and started his own company, Outbox. And without further ado.
Thanks. How's it going, everybody?
Good.
Nice. You guys are surprisingly high energy for how late in the day it is. This is great. I always like checking out the stickers on everyone's laptops to get an impression of like what people's backgrounds are. But how many people here have built like an application with JavaScript before? All right, cool. What kind of frameworks you guys use or libraries? Anyone want to volunteer? Angular, okay.
React.
Sorry? We got Ember over here, Angular over here. Someone yelled React.
No.
Backbone, all right.
And D3.
D3, okay.
Meteor.
Meteor? Cool.
Roll.
Raw. Oh, like vanilla JavaScript. The true hipster framework. Okay. Cool. All right. So we got like a lot of experience here, which is good. So my name is Pete. I was at Facebook for a while, doing a bunch of stuff, working on Instagram stuff for a while. Recently started a startup, pretty unrelated to front end, but doing a lot of fraud and spam detection stuff. Well, when I was at Facebook, I built kind of the first big application with React. And then when I was working on it, I realized that there were all these problems with React and it wasn't ready for prime time. So I ended up being on the core team of React for a long time and pushing it through open source and building a bunch of features there. One of the reasons why I was motivated to do that was because I really, really love the web. I think the web is like this great technological marvel that we have, and it kind of defines our generation. So I ended up leading the web team at Instagram while being also on the Facebook JavaScript infrastructure team. This is a team that kind of goes around and figures out the best ways to write write JavaScript at Facebook, and we kind of go and sell different techniques to product teams. I was also on the React core team, and I really like the web, especially because it's everywhere. Like anywhere you go, like any device that you use the web. At the same time, I really hate the web, like a lot of things about the web. It's a terrible API for building applications. So the guy who did raw JavaScript, vanilla JavaScript, like you're hardcore, like props, because it's really hard to build applications without help. And even though we have some upcoming standards called web components that make this a little bit easier, it's still like a very, very hard API to use. It wasn't designed for building applications. Another thing that I really hate about the web is DOM manipulation is really slow. You guys know what the DOM is? All right, pretty much everyone's nodding their head. It's the, in case you didn't nod your head, it's the way that a JavaScript application interfaces with HTML and can change the page. And it's really slow, and the slowest part about it is layout. So when you change a part of the page and you have to change the way that text wraps around something, that's really slow. And understanding when it's going to trigger a fast layout change or a slow layout change is pretty difficult to understand without a lot of experience with the like kind of web inspector and all those tools. And the Google Chrome team in particular is doing a great job building tools to make this easier, but it's still really hard to understand. Another reason why I hate the web is the standards process is really slow. But this is actually by design, so it's kind of a good thing. The reason why the web is everywhere is because it is standardized, and that means that all the implementers implement the same thing. So we can deploy an application once and have it run anywhere. But it also means we don't get a lot of features, and the features that we do have are designed by committee, and they tend to be slow. But at the end of the day, the biggest problem is that we're building the web is designed for documents, and we want to build applications. So Facebook needed a solution to this problem. We were sick of building applications that looked like documents, and we wanted to build applications that performed like applications and felt like apps. So does anyone here know, like, can someone tell me what an application is on the web? Like, what does it do? No? Okay. Are you guys CS students? I don't know. All right. So the way I think of an application does basically three things. It listens for user events from the browser, so it gets clicks, keystrokes, mouse movements, touch events. It handles network events, so a request coming in from the server via either an XML HTTP request or WebSocket, and it also issues network requests as well, and it manipulates the DOM. That's pretty much all it does. Basically, it responds to events and puts pixels on the screen and sends stuff to the network. It's actually like a pretty difficult thing to do once you start to write an application. And I think that Dijkstra had a lot of really great advice for us, kind of back in the 60s and 70s, about how to write great applications. And he says, we should do our utmost to shorten the conceptual gap between the static program and the dynamic process to make the correspondence between the program and the process as trivial as possible. What the hell does that even mean? I'll tell you what it means. This is a buddy list on Facebook.com on the desktop site. Now, I'm going to read to you a series of network events coming in from the server, and then I'm going to ask you what this looks like at the end. You guys ready? Alice went offline, Bob went offline, Steve went online, Bob went online, Charles is idle, and Charles is on mobile. All right, what does it look like? These processes that evolve over time are really hard to understand. Like, holding all that state in your head is crazy. It would be a lot easier if I could ask you what that looks like by just looking at this JSON data structure. By looking at this, you could probably draw a picture of the buddy list pretty easily. That's because this is a static snapshot in time of what the buddy list should look like. It's not a series of events, mutating state that changes over time. You feels me? All right. So have you guys heard of this thing called data binding? The Angular people probably have, Backbone people maybe as well. It basically takes the user interface, which is a dynamic process that changes over time, and it tries to make it look more like a static program. So you take a snapshot of your data, and some system somewhere syncs up your user interface with that data. And so I like to think of data binding as a polyfill for reactive JavaScript and the DOM. Now, for those of you not familiar with what a polyfill is, it's a JavaScript library that kind of makes a feature that's available in the next version of JavaScript or the DOM available today. It's like a shim. And what data binding is it's basically a way of saying, like, hey, I wish that the DOM could automatically update itself based on variables in JavaScript. Let's make it work. Now, the problem is that these data binding abstractions that we have are leaky abstractions. And they're really, really not simple. So Facebook had a traditional kind of data binding approach a couple of years ago. It was called Bolt. It's actually still on GitHub, I think. And it ended up getting very, very complicated very quickly. And the thing that made it difficult was that we would build an application and it would work. And then we would play with it for a while. We would get these bug reports that come back in that say, hey, the user interface is broken, or this button doesn't do what it's supposed to do. And we couldn't reproduce that bug report. So the most important thing that we realized is that we want to just have reproducible bugs. Like, we don't even care if the thing's easy to make or if it works, but as long as it breaks consistently, like, we'll take that. That's a win. So Dijkstra, again, says simplicity is prerequisite for reliability. Reliable systems are predictable. So how do we make a system simple? Now, simple is one of these words that gets thrown around all the time. And you ask two different JavaScript library authors, like, which one is simpler, they'll always say theirs is simpler. Even though, everyone has a different idea of what simple means. But does anybody here know who Rich Hickey is? Has anybody heard of the Clojure programming language? Okay, so Rich Hickey is this guy with this huge afro, and he invented the Clojure programming language. He's super smart. And he has this great talk that I suggest everybody goes and watches called Simple Made Easy. And at the end of the day, he comes down and he says, what matters for simplicity is that there's no interleaving. So Rich makes a distinction between what is simple and what is easy. So easy is something that's relative. What's easy for you might not be easy for me, or what's easy for me might not be easy for somebody else. It's all dependent on what our experience is. Some people find like C programming really, really simple and building user interfaces in JavaScript really difficult. And sometimes it's vice versa too. Some people, it just matters what your experience is. But simplicity, we can make that actually an objective thing. And we can say, hey, when you're looking at a single piece of code, how many different concerns are interleaved in there? How many things do you have to load into your brain to understand what that piece of code is doing? So it's important to understand that simple is not equal to familiar. And so just because you have experience with a piece of technology, or the status quo says you should do something, doesn't mean it's simple. It means it's familiar, and it might mean it's easy to you, but it doesn't mean it's simple. So we're talking a lot about data binding, and there's a couple of approaches that you can take to implement data binding. The first one I'm going to talk about is KeyValue Observation. Because in order to understand why we actually built React and did something different, you need to understand what the status quo was. Because you really shouldn't invent something new unless you have something new to add to the conversation and the body of knowledge. So KeyValue Observation powers libraries like Ember, Knockout, Backbone, Meteor. If you've ever done any iOS development, there's KeyValue Observation in iOS as well. And it's built around the ideas of observables and computed properties. These are the fundamental building blocks of a key-value observation system. So let's imagine, for example, for this lecture, that we're building a list of top companies by the percentage of votes that are upvotes. So we have a data structure sitting around somewhere like this, where we have a list of companies, and each one has a title, number of upvotes, number of downvotes. And I'm an amazing designer, so I rendered a UI that looks something like this. If we were to build that with Ember, we would construct a template that looks like this. And what this says is it creates an unordered list with a UL tag. And it says for each of the top companies in that data structure, render the title, and then next to it, render the score with a percentage. Now remember, we didn't actually have a score item in that data structure. All we have are the upvotes and the downvotes and the title. So we have to compute that score as a percentage. So let's walk through how we would build the JavaScript portion of this application with an eye towards how this abstraction leaks. So first we make a function that computes the total votes given a company. Now I'm going to use Ember for this example because it's a very, very popular implementation of KVO. And those teams have spent a long time trying to make this as predictable and easy to understand as possible. So the observable properties that we have here are called upvotes and downvotes, and you call company.get to get the current value of them. So we get the current value of upvotes and downvotes, and we add them. And our company object has a computed property on here, which is indicated by that dot property called score. And it takes the number of upvotes, multiplies by 100, divides it by the total number of votes, and it converts it to a percentage. Now, one thing to keep in mind with computed properties is that dot property syntax says, hey, whenever the upvotes or the downvotes change, make sure that the score is recomputed. You guys following what's going on in this code? Okay, cool. So similarly, in the app model, whenever the list of companies changes, we want to change the list of top companies. And the reason for that is we're resorting this list. So top companies is a sorted list by the total number of votes. So it's the most popular companies. And then finally, we instantiate it with a little bit of boilerplate down here, which is mostly made up. But you get the point. So if we were to run this today, I actually built a little test app that randomly changes the number of upvotes and downvotes by plus or minus 5 as the application goes on to simulate live updating data. And so when you're running that application, it looks like this. So you see the numbers are automatically updating, right? I'm tweaking the data model and the DOM is updating. I'll replay it again if you didn't see it. It's very exciting. This looks good, right? You guys good with this? All right. So you guys just approved my diff, and we're going to ship this to production. That's what happens in industry.
It's not resorting the list. One is low, the second item is lower than the third item.
Interesting observation. So I've used this example in like 3 or 4 conferences, and nobody has caught that.
Yes.
So the point of that, all right, A right there. The point of this is that like everybody else in this room didn't see that. So it's actually pretty difficult, or it's very easy for this bug to slip by, right? So where is that bug in this code? Now you're really on. So the problem is the sorting was wrong, right? So it's probably in this top companies thing where we sort by the total number of votes, right? What? No, yeah, go.
I think it's taking the top 3, but not sorting them by the number of votes they have.
Well, we're calling the sort method in JavaScript, and let's assume that the sort method actually works correctly. Like that's not the problem, but that's a good check. Yeah.
the property isn't for upvotes and downvotes in top companies, so when the upvotes and downvotes change, the sorting doesn't rerun.
Exactly. So what he meant is, right now we're saying, hey, when the list of companies changes, re-render the top companies list, right? It's not looking at the individual items within the list. So when you mutate an individual company within that and you change the number of votes, you need to observe that and tell top companies to update. So the way you do that is with this glorious syntax. This is like a thing that Ember made up. Okay. Actually, I think they might have borrowed it from Apple, but like somebody made this up who was not like a long dead computer scientist. And I like using stuff that long dead computer scientists have made, or people who have invented a language in like 10 days, like JavaScript. But, whatever. The point I'm trying to make here is not that this is a tricky API, it's that it's not simple, right? We're thinking about our business logic here. We just want to sort the damn list. But with this, I have to load the part into my brain that's like, how are we tracking changes throughout this? So not just thinking about how my application works, I'm thinking about how do I tell the framework to track changes in this data structure? That's interleaving, and that's another thing to put in my brain. So once we make that change, they're resorting all the time, just as they should. Now, we fixed the bug, which is great, but we just solved the problem. We shouldn't have had that problem in the first place. This section, yeah. You guys going to ask a lot of questions later? Take it as a no? Okay, so we'll go through this section. All right, I'll just blow through this other example really quickly. Here's another problem with KVO. So this fixes some of the problems of the previous type of KVO. This is a system called Knockout. And imagine we're building a stock trading app, or a stock purchasing app, where the share price is changing all the time, and we want to order a certain number of shares, and we see the cost changing. Okay, and we want to purchase stock. We use another domain-specific language. Rather than handlebars in our previous example, we use HTML attributes to annotate our DOM for Knockout. What this says is basically, okay, I want to bind the text of this span to this format currency function, whatever that current value is. This input binds the value of the input to the shares, so whenever somebody types into the text box, the variable shares gets updated. And then we update the total cost by computing the cost. We bind the value of the total cost span to whatever this format currency cost thing does. Okay. This make sense? Okay. So we have a format currency function. Basically just slices off all but the last two digits of digits of precision. We have a stock view model, which is our model that we're creating. Remember, we referenced the price and we referenced shares. So those are two observables. The price we have in this example just randomly varying, and the number of shares is initialized to 0. And then the cost is a computed property, just like in our previous example, except in this case, we don't have to explicitly list off what our dependencies are with that .property syntax. We just call them as functions, and the system figures it out. So if we wanted to make this a little bit more flexible, and we want to either buy a certain number of shares or a total dollar amount of shares, things get pretty crazy. So this field is changing all the time. It becomes very difficult for me to insert something because I lose my cursor position, and it resets my input sometimes. And that's because we have to make a change to our computed property, because the price and the amount of shares that the user is entering are fighting over what is the canonical source of truth for this value. So we have to add some of that crap. I don't even know what it does, but that's what you have to do. Anyway, on to Angular. So I covered KVO both in its explicit form, where you list off the dependencies, which has a lot of very easy to understand bugs, and implicit KVO, where you can still see these problems with data flow and arguing over who is the source of truth. The third approach, which I think is better than the KVO approach, is this thing called dirty checking, which was popularized by Angular a couple of years ago. And this is, again, I'm a great designer. This is a very common unit on Facebook, believe it or not, where you put a profile picture next to somebody's name. And we put those everywhere. So let's make a reusable component for that in Angular and see how it works. So we start by creating this thing called we basically use this thing called a directive. So FB avatar is that component. In Angular, it's called a directive. And we say, hey, create this FB avatar and use the current user that my controller is providing. Does this make sense? I don't blame you if it doesn't because it's Angular. No, I'm just kidding. But so I'll get into how the scoping stuff works. But basically, this user equals user thing refers to a variable in the scope that controller provides. And it'll make sure this avatar is kept up to date always. So the way that we do this is in Angular, we create a new module. We create a controller on that module, my controller. Then this $scope thing is where those variables are looked up. And so we initialize the user variable on the scope to be my user object. You could imagine this being fetched from the server somewhere, sent down to some payload. And then we want to actually render this data structure. So we say, OK, create this directive called FB avatar. And this is our specification for how it should be rendered. So I don't actually know what restrict E means. I think it means restrict it to an element. You can only use it as an element, but that's an implementation detail. But the point is that this says, hey, render this template, and then make sure that the user always updates when the value on the scope updates. So that's where that user equal sign thing means. And we're also using this FB pick directive that we can also define. So we can use composition here. Or we say, OK, I want a reusable profile pick component that we might use in a different UI. So there's like face piles in Facebook. And then we want to reuse it in this other media object. Now the problem here is that we can't actually use our existing JavaScript tools to understand this. So if anybody's ever used a linter before, like JS hint, it doesn't understand what these strings do. These are just opaque strings. So if you want to know whether you're using a directive that hasn't been defined, you're SOL. You've got to run it, and you've got to hope that you hit that code path. And it's really, really difficult. Also, if you want to get a stack trace, if this directive throws an exception and you want to see what other directive was creating it, it's very difficult to get that as well. That's because we're rebuilding a lot of JavaScript in order to use dirty checking. And what dirty checking does is it just goes over everything in scope and checks, hey, is the previous version equal to the next version? And so you have to pass everything through this scope, and you have to use directives in order to build your application, not functions. The point isn't that you can't build applications with these, it's that there must be a simpler way. And the Angular and Ember and Knockout folks focus a lot on developer ergonomics and making things work as well as they can, but I just think that they're built on some fundamentally worse ideas. You might be thinking web components right now. I'm kind of coming around to the idea a little bit. There's a lot of stuff in the web component spec that is nice, being able to customize how selects work, for example, like dropdowns. So there's a lot of great stuff in web components, but it's not going to be the way that you structure your application. And that's what React tries to solve, is how do you structure your application, manipulate the DOM. Web components is kind of more of the same regular DOM API. So I kind of think of it as standardized worst practices. It's kind of a bummer. What if we had a reactive JavaScript though? Remember, we talked about like a polyfill for reactive JavaScript in the DOM. So let's look at this example again. Remember this? The most voted companies at the top, and then the percentage of the votes that are upvotes. Now, we had to hack around this and create all these observables or pass things through scope in order to get this automatic updating, right? Otherwise, in JavaScript, if you update a variable, all of its dependencies aren't automatically recomputed, right? Because program flow goes from top to bottom. But imagine that they were. So we could write our JavaScript like this. We have the same stuff at the bottom, basically. We get our JSON model, and then we render the application into the body. We have this function that does the rendering. We could create a regular JavaScript function that says, hey, add the number of upvotes and the downvotes to get the total number of votes. We don't have any getters or setters here because these are regular JavaScript values. You need getters and setters if you're using observables and computer properties. Then we could have some helper functions that create the DOM for us. So we could say, hey, I want an unordered list. And what I want to do is I want to sort the number of companies that we have, or I want to sort the list of companies we have by the total number of votes. I want to take the top 3. And then for each of those companies, I want to return a list item that shows the title and then the percentage of votes that are upvotes. This is all just regular JavaScript. There's no framework involved here. We have some helper functions to create the elements, but other than that, this is plain old JavaScript. Slice, map, summing stuff. Like, it's all pretty basic stuff. And what's great about that is that since JavaScript is, like, by some definition, a real programming language, you can actually use regular techniques for abstracting stuff, right? Like, you don't have to create these directives, and you don't have to create observable and computed properties. You can just say, oh, that expression in there looks like pretty ugly. I want to pull it out into a function. And you just do it like that. You know how functions work? What's also pretty cool is that we could unit test this separately too. Imagine that this is like this big complex piece of UI, possibly reused in multiple parts of the code base. You want the team that owns that reusable piece to be able to test that separately from all the places where it's used. Again, if you can't think about individual pieces separated from each other, then that's more stuff you have to load in your brain, and that's not simple. So we can't do this today because JavaScript is not reactive. And more importantly, the DOM is stateful. So the way that you interact with the DOM is you say, hey, I want to set the text of this element to this, or I want to change this color over here, and then it sticks. And then if you make another change to the DOM, that change that you made previously is still there. And this is just like that buddy list example I gave earlier, where you've got all of these events going, and you're thinking about all this mutation over time, and it's very difficult for you to predict what does a whole page look like at a given point in time. So rather than deal with the stateful DOM, the React team created something called the virtual DOM, which we like to think of it as a less leaky polyfill for reactive JavaScript in the DOM. And it's used in a lot of places. I actually have these slides left over from before React was like super popular. But it's used in our search product, our insights product. It renders these charts. And before my big OMG about React was like, hey, it renders interactive visualizations on Canvas and SVG and VML. But now I can say it actually like renders native UIs on iOS, which is pretty cool. That was announced last week. We use it on our mobile website as well to upload photos and to handle the navigation. Instagram.com is built entirely with it. And the best part about it is that this code example right here is actually valid React code. So you could run this in the browser today, and it will get live updating data, and it will render it for you. And remember, there's no data binding artifacts here. I'm just simply expressing the logic of my application. I'm not thinking about how is this data kept up to date. It's just magically done for me. So how does this work? We have something called a virtual DOM diffing algorithm. And so the model we like is whenever any piece of data in your application may have changed, re-render everything. Now that sounds crazy and it sounds like kind of annoying, but it's actually really, really nice, right? We're not thinking about like the buddy list. We're not thinking about event A, B, C, and D over time. We're just taking a snapshot of the data model and then we're re-rendering everything in one pass. So you can just fit all of that stuff in your head without thinking about the entire history of what your application's done. And so what React does is React re-renders everything to a virtual DOM representation, which is fast, and then it diffs that representation with a previous representation, which is fast, and then it only updates the DOM with what actually changed. So for example, if you render a div with a class name, and that class name attribute changes, React will figure out, hey, that div is still there, so don't recreate the element, just change the class name property to be what the user wanted it to be. And this leads to like the ability to build really expressive applications. So this is some definition of expressive power, but I like this one better. It's called practical expressivity, which is the measure of ideas expressible concisely and readily in a language. So how much typing does it take to express something? How much stuff do you have to put in your head? And so if you think about all the examples for where we did data binding versus the ones where we used React or the virtual DOM, we had to fit a lot more, we had to type a lot more code and put a lot more in our head. But the reason why people tolerate this low expressive power of data binding systems is because they think that re-rendering and diffing is prohibitively expensive. This is why this has never been done before. Because people think you can't re-render the whole application. They think that's going to take a while. And then they think walking through every single thing that you re-rendered and checking what changed is also going to be expensive. So nobody tried it. They just tried to track, what is the underlying change in my data model, and then propagate that through to the DOM with those computed properties or dirty checking that scope. This is a great quote. Every system has constraints, specifically around cost. So like I said, KVO entangles your application code with observables. You've got to think about how your data is being kept up to date when you're doing KVO. Angular-style dirty checking means you're not allowed to use functions anymore to build your application. You have to use directives. And the virtual DOM also has constraints as well. It's not perfect. It needs a signal to say something may have changed in your application. That's it. This could be object.observe. This could be any event. The signal that React uses, if anybody's used it before, is called setState. It's a method that you call when something has changed in your application. Now, the key thing to think about with this, is that KVO, your observables are entangled inside of your application. So when you're building your application, you're always thinking about it. With Angular, scope is always throughout your application. With Virtual DOM, this signal's at the edge of your application. You build most of your application not worrying about it, and then at the very edge, you have this signal that says, hey, something changed. So this is why we built React, is to get these properties. But we also had the opportunity, because we were just kind of building a system based on JavaScript, we had the opportunity to do it right from the beginning. So we were able to avoid domain-specific languages when we were building this. And the reason for that is that when you introduce domain-specific languages, so these would be like the magic HTML attributes to inform data binding, composing things with strings, you lose static analyzability. So this is linting, minification, and type checking primarily. You can't type check a system based on KVO unless the type checker understands what those strings inside those getters and setters mean. You can't, it's very difficult to type check a system based on Angular as well because you're composing those directives with strings. Now, whether those strings are actually in JavaScript strings or the DOM, it doesn't matter. You still need to build a custom type checker. And you've actually seen this for minification on Angular. There's ngmin, which they had to do because they're building so many domain-specific languages. So I've talked a lot about the reasons why it's simpler to develop with a virtual DOM, but there's still that big question about performance. Like, can we do this? Can we re-render the whole application, diff it, and then update the page? Now, performance is this very, very difficult topic to fully. You can never really say something is more performant than something else, because there's a lot of stuff. There's CPU, there's memory utilization, there's cost, there's programmer to developer time, all that stuff. But one thing to really keep in mind is mobile. Is memory on mobile. And it's almost as more important than CPU. I'd actually say it's more important than CPU. So does anybody know what happens when you allocate too much memory on the mobile web? Anyone know?
Paging?
The app crashes. So the app exits. If you use too much CPU, your app is slow, but you can still kind of use it. So the choice is you need to have a shitty user experience or no user experience. So I care more about memory a lot of the time. So the KVO bookkeeping is not free, memory and CPU. Remember, we have computed properties that depend on other computed properties that depend on values that change. You have to maintain this graph throughout your entire data model to understand when a value on this side needs to change as a result of a change on this side. On the other hand, your render code is usually pretty cheap. If you've ever built a front end before, it's very rare that you have loops that can go for more than a couple hundred iterations. Because your render code is generally rendering pretty few pieces of information because humans can only process so many pieces of information. So what usually ends up happening is that your view is usually a lot smaller than your underlying data model. Think of any application you use. The Facebook newsfeed, there's so much data underlying that feed, but we only surface some of it. So I'm going to throw out some numbers. They're not comprehensive and they're about a year old. There have been performance improvements on both sides since then. But these numbers are to illustrate big O complexity rather than to be kind of the concrete, hey, on a 2012 MacBook Pro, Angular renders a list of 1,000 items this quickly. So we want to look at how these numbers grow. You guys know big O complexity? Like, okay, cool. This is like actually a practical use of it. Cool. All right, so this awesome application that we keep coming back to, right? I built it in React, Ember, and Angular. And the numbers at 25 items look like this. This is basically I did 3 types of things. I did an initial render time. I did a bunch of updates and then measured the time once it was warm. Another thing when you measure JavaScript, if you're doing it in a JITted environment, which is pretty much every environment except for web views on iOS, iOS 7 and earlier, you need to warm up your application before you can really get an idea of what steady state performance is. But also, you have to think about, hey, startup time is important too. So there's all this nuance. But I tried to measure initial render, warm updates, and then the steady state memory. So after this thing has been running for a while, what's the memory usage look like? And at 25 items, it's pretty much even. Like, there's no real difference here, right? There's a little bit of memory difference, a little bit of render difference, but nothing like super important. But when we bump this number up to 10,000 items, we start to see a pretty big difference. So the initial render time gets to be pretty big. Warm updates are still fairly large. But the steady state memory grows quickly. Boils down to O of n. So we all know what this means. This is linear growth. This line that looks like this, right? It's actually important to break this down, and you need to understand what n is. So I'm breaking this down actually to O of v versus O of m. So v is the size of your view, so the amount of data that you're putting into the view, versus O of m, which is the size of your underlying data model. And remember, like we mentioned before, most applications that aren't micro benchmarks tend to have a lot more stuff in the model than they do in the view. You're usually only looking at a couple of pages of data, and underneath it there could be hundreds or thousands or millions of records. So if I think about kind of the things that have had performance problems on Facebook in the past, those would be things like sortable data tables on our ads product. So you have a big giant list of all of your ad targeting stuff and you want to sort a column. A search type ahead on mobile. So as you're typing in your friend's name, it's constantly resorting that list and you don't want it to delay your key presses on the keyboard. Some stuff on timeline as well. So if you squint at it, it looks kind of, the complexity looks kind of like this for CPU and memory, for KVO and the virtual DOM. So let's think about how KVO works, remember. We have a graph of observables that eventually end up at the DOM, and over here is your underlying data model. So when we trigger an update in your data model over here, it only updates the exact pieces of data that need to be updated. It's effectively a constant time operation with respect to the view. With virtual DOM, we have to go through and we have to re-render everything, then we have to diff it, right? So that's basically an order of V operation, where we're walking through everything that you've possibly rendered, and we're checking everything to see if it's out of date. That seems like a lot slower, right? And it is. I mean, it's the warm updates are O of 1 versus O of V. Now, when you look at memory usage, though, we have O of m versus O of v for KVO versus virtual DOM. You have to keep this entire graph of every single possible computation that your KVO-based application is going to do in order to know what to recompute. Whereas with virtual DOM, it doesn't track anything in your underlying data model. It only tracks what's rendered. So if you're only rendering a little bit of data and you have this huge complex model, then you don't have to track anything in the model. You just track a little bit of data. So a good example is if I had a row of, or I'll get you a question in a sec. If you have like data table with like 10,000 rows in it and it's sortable, and you want to sort a column, in React, you just sort that on demand when it's clicked, and then you only render those top couple items. And then you diff those top couple items that are in the viewport. With something like Ember or any KVO-based system, you have to maintain a data graph of everything you could possibly sort on, and maintain callback graphs to every single place where it could possibly be rendered. It's actually very, very expensive. Did you have a question?
Yes. What's M?
M is the size of your model. So the way that I think about it is you have a big data table. You can see maybe 10 rows of the data table, but underneath it there could be hundreds of thousands. And this is generally when you have a performance problem, it's types of applications like this. So I've shown a pretty like pro virtual DOM performance situation. Let's show a really bad one. Let's show one where the view is much larger than the model. So we have 1,000 items in our model, and we have 10,000 DOM nodes. And we're going to update a single one. So we're going to update a needle in a haystack. Remember, so this means we're going to diff a ton of stuff, and only one little thing is going to change. So this is what the numbers look like in the very, very kind of pathological case for React. You can see that React sucks, right? Like, memory's good, like memory, but CPU is pretty bad, especially in this warm update in particular. Like, that is orders of magnitude faster. Initial render's still good, though. So if you have performance problems in a data binding system, the solution is generally to disable data binding. That's what people do. If you go look at the Angular documentation, they say use bind once, which is a euphemism for like turn off data binding, which is the whole point of coming to Angular in the first place. With virtual DOM, since it's just JavaScript, you solve performance problems in the same way that you would solve performance problems with any regular software system. And it's generally using a technique called memoization or caching. So you take values that you're recomputing frivolously and you cache them. So React has a hook called shouldComponentUpdate. And it's basically a function like this. So every row in our example of companies, we can determine whether or not we need to update it by this simple comparison. We compare 2 integers, or we compare 4 integers. Really, really quick to do that. You don't have to go and diff all of the elements inside of that DOM. You just run that. And we have profiling tools that help you find these. So when we add a hook like this, so every row in that example application, we have to run this instead of like the virtual DOM diff. Okay. When we add that hook, we bring down the warm updates to 7 milliseconds, which is still an order of magnitude slower than KVO. 10 times slower. But the thing is that we lost a ton of performance on the initial render, and we know how the memory is going to grow in a real application. It might be prohibitively expensive on mobile. And we lose all of that for a pathological case of under a frame, which isn't even user perceptible. So this is the trade-off we're making. Your intuition says, hey, this diffing should be like way too expensive to be practical, but in reality, it takes a little bit of optimization in some corner cases to get it down to a point where it doesn't matter, and there's a lot of other benefits. So then there's some other stuff around performance as well. It's not just about CPU and memory. There's page load performance as well. With React, it's just JavaScript, so you can use all the packaging tools out there that you use. So minifiers, different bundlers, all that kind of stuff. Can also do server rendering as well, but that's not super interesting. That's kind of a sales pitch. Thanks. All right, so does anybody have any questions? Okay. So what we want to do is we want to say, React is a function that says, given this and this, turn it into DOM operations. So the desired output that we want is basically like document or like element, some DOM element dot remove child, this thing. Okay. So what React will do is it'll do a traversal of these two data structures, and it'll say, hey, okay, first here, is the type the same? So is it a UL? Yes. Okay. So we go to the next one. We say, is the type of this type the same? Yes. Okay. So we go to its child, which is a text child, and we'll say, hey, is the type the same because it is text? Yes. Okay. Then look at the value of the text. Value is high. Move to the next one. So then this says, hey, is the type of this the same as the type of null because it's missing in the new one? And React identifies like, hey, this element is no longer there, so we'll remove it. So that one's pretty simple. But if we actually wanted to insert a new element, it gets a little bit tricky, right? So let's say we do so this is something that's somewhat tricky. When we diff this, we see a new element has appeared, right? We don't actually know whether we should reuse, whether this one should be first, or whether we should replace the, or actually, let's do this. So the thing with this diff that makes it hard is that we don't know whether we should move this one down and insert a new node above it, or whether we should replace the text of this node and then create a new node below it. You get what I mean by that? Okay. So what React does is that when you're specifying a fragment of these nodes, it automatically assigns keys to them. So it will give this basically index 0, 1, or this is actually 0.0. And then this has key 0, 0.1, or 0.0 and 0.1. And then it uses those keys to determine whether or not a node should be reused or destroyed. What React does is it automatically, kind of implicitly assumes that like this is going to be. It basically automatically assigns keys. So in this case, it's automatically assigned 0.0 here, and 0.0 here, and 0.1 there. So in the naive case, it will replace the text of this node with the text by, and then create a new DOM node that contains the word hi. Does that make sense? Yeah.
What are your thoughts on ohm?
An ohm?
Yeah.
Sick of the virtual DOM diff?
What was that?
Sick of the virtual DOM diff?
Oh,
No,
not really.
that's cool.
Sorry.
Basically, the one final thought on that is you can override the automatic keying that React gives you by assigning a key attribute. And so you can control how those nodes are reused. As far as ohm goes, it's a bunch of like really interesting properties. They use these set of data structures called persistent data structures that allow you to do really, really awesome performance improvements. So I showed you that example where there's the should component update where we compare integers. You can actually compare entire data structures very quickly. Are you guys familiar with persistent data structures at all? I'm not seeing a lot of nods, but basically they're an immutable data structure. So if you have a hash table that has a couple of keys or values, in a traditional hash table, you can change one of those keys to be a new value, or you can replace one of the values in that hash table. And if you want to check if that hash table has changed, you basically have to copy the original one and walk through every single item in that hash table to determine if it's changed. With a persistent data structure, you create an entirely new hash table whenever you want to make any change, and you fill it in with all the old values and just change the value that you wanted to change. So you can just check the pointer pointing to that hash table, and if they're the same, they're guaranteed to be the same object, and if they're different, they're guaranteed to be different. So what ohm does, it's the closure like wrapper around React. It builds that in kind of automatically to everything. So basically all of your data structures are immutable, so it can automatically insert those optimization hooks at every single level of the component. So your application like theoretically gets a lot faster like right out of the box because of how the language is designed. That answer your question? Cool. Okay.
It sounds like React is completely responsible for rendering everything that you want to change. Does that mean you lose the ability to like, I don't know if you can render custom, like if you have a canvas element that you want to like customly render, how does that fit in to React?
So the question is, how do like custom elements and jQuery plugins and stuff like that fit into React if React is doing all the rendering? Every component that you make has a very, very specific life cycle. And so a life cycle would be, they're called will mount, did update, did update, and will unmount. That is basically like a constructor, an update method, and then a destructor. And what you would do is you would render a single virtual DOM element. A lot of times it's just a div, so when React runs its diff, it doesn't make any changes because it's the same thing each time. And then in your will update and did update methods, you can call jQuery or you can draw to the canvas. That makes sense? How are we doing on time? All right, we got one more question. Oh, you want to know about React Native? Sure. Okay, so the question is, what's the deal with React Native? Has anybody heard of React Native? So want to take a pass at explaining it? Yeah.
It pretty much lets you develop for mobile with React, basically, and just lets you, yeah.
Says the guy with the Facebook share. Nice. So yeah, it lets you use JavaScript and React to develop native applications. But more concretely, remember this example where we said, okay, React is basically a function that takes an old tree and a new tree and emits DOM operations. So this document.append child and remove child and insert into an HTML, those types of things. There's no reason why those operations have to be DOM operations. So what React Native is it's just a plugin into React where when it diffs these trees, rather than emitting DOM operations, it emits create UI table view, or update this delegate, or something like that. Like basically turns it into Objective-C, or calls into Cocoa and Android SDKs.
Yeah, I have a question on that. So to do that, like you pretty much have to have a JavaScript engine inside your app, right?
Yep.
So does that like contribute a lot to like app size and what not? Is that something that you guys have tried to optimize, or?
The question is, do you have to ship a JavaScript VM? The answer is most, like iOS has JavaScript core built in, so that's not an additional kind of bloat to your binary.
What about Android?
I don't know what the deal is with Android, unfortunately. I didn't contribute to React Native on Android. I think that's all the time we got.
Okay, great.